So everybody's seen aircraft. A lot of people have flown on aircraft. How do they work? What makes it go down the runway? It starts at rest, it's big and heavy. What makes it go down the runway? Well, something strapped under the wing called an engine. True? Now, the components of that engine, here's a cross-section of a jet engine. You have air inlet. You then go through a compressor, right? And then you go through combustor. And then you go through a turbine section. And then exhausting the gases. That's how it works. Now, for the stationary gas power plant, there was a compressor, combustor, and a turbine. So what's different? And how come this gives us the propulsion to make the aircraft fly? Goes down the runway, gets so fast, and all of a sudden, oops, it's airborne. Well, how does it do it? So I thought I'd start with another video, but the video is too long. So I encourage you to go out and look at this video or other videos. They really help you visualize what's happening. It's like if a picture's worth 1,000 words, what's a good video worth? Probably 1,000 pictures. But let's do this. Let's see, test your knowledge. The main purpose of a jet engine is to generate internal energy, momentum, kinetic energy, thrust, or energy. What is the main purpose of a jet engine? It's to generate what? All right, I'm going to go ahead and shut it down. And let's show the results. Very good. But this is great, 91%. It's thrust. All right? That's what it generates, thrust. So that propels the aircraft down the runway. Well, here's the next question. What are the SI units of thrust? Kilojoules, kilonewtons, meters per second squared, or kilowatts? All right, I think everybody's in. So let's go ahead and shut it down. And we show the results. So units of thrust is equivalent to a force, isn't it? So that little contraption hanging on the bottom of a wing, here's the wing, this little contraption right here, essentially puts, when it's running, it's throwing a force on the bottom of the wing in the positive x direction, moving the aircraft down the runway and up into the sky. It's accelerating the aircraft. When it reaches cruising speed at whatever cruising altitude, it's still generating a forward thrust onto the aircraft to counter the drag force, so it can stay steady speed of flying at that altitude, not go down, anything like that. So it's a force. So it's units of kilonewton. How does this thing work? How does the jet engine work? How does it generate a forward thrust? So you can go and break it down into components. First of all, the compressor, the combustor, and the turbine are what you've analyzed before. True? You can put on the front of it a diffuser. If your aircraft is going at a high speed, then usually you need to do something to the incoming flow because it's so fast. You need to put a diffuser on it. What's the purpose of the diffuser? Decrease the velocity. What will happen then, so the velocity at A is too high, you bring it down to the velocity of 1 is much more manageable, lower, right? Okay, what about the kinetic energy, the incoming flow at A, and the kinetic energy at the outgoing flow at the end of the diffuser? Much greater, right? Because the kinetic energy is proportional to the velocity squared. And so essentially this is negligible. KE at 1 is negligible. Okay. Didn't say the velocity at 1 was negligible, but the velocity squared at 1 is negligible in energy balance considerations. Now the harder ones are temperature. What happens to the temperature? What happens to the pressure? What does the pressure go up? Stay the same? Go down? What does the pressure do as you go into the diffuser? The purpose of the diffuser is slow it down. We have a vote for go up. I got a vote for down. Anybody unchanged? We got a vote for unchanged. So what is it with confidence? It'll go up. Yeah, so this is pressure is higher. What about the temperature? Same, up. Anybody down? Down, sure. It's all over. Same, all right. If this diffuser, do you think S equal to a constant might apply? A really good diffuser, isentropic flow through the diffuser, the pressure went up. Do you think an equation like T2 over T1 equal to P2 over P1 to the K minus 1 over K? We're putting air through this is ideal gas, right? Ideal gas, isentropic diffuser, best diffuser, good diffuser. What do you think now? Pressure went up. Temperature goes up too. Temperature goes up. Very good. Now another question is you have an idea of an engine. Now let's talk about the pressure A before it comes into the diffuser versus the pressure B after it exits the nozzle. Okay. What about the pressure difference? 1 inch before the diffuser. 1 inch before the diffuser and 1 inch after the nozzle. See, I'm not talking about inside the nozzle or inside the diffuser. It's what comes into the nozzle and out of the diffuser. Into the diffuser and out of the nozzle. So what about the pressure at A versus the pressure at B? Greater, equal, less? These are very, very tough questions. Who's passed fluid mechanics? Only those that have passed fluid mechanics? Give us the answer. They're equal. So the streamlines are straight. There's no radius of curvature. And the pressure outside is the same as here. And then as I march, the pressure goes through. It's the constant pressure, PA, and equal to PB. Very good. So we got that the pressure at B is equal to the pressure at A. But for this nozzle, what about the pressure to feed the nozzle? Should that be higher, equal to, or less than the pressure at the exit of the nozzle for a good nozzle? Greater. What about the temperature compared to the temperature to exit? Greater, equal to, less? It's going to be hot and high pressure. Feed hot, high pressure to the nozzle. What about the kinetic energy at the exit versus the kinetic energy at the inlet of the nozzle? This is essentially zero, just like KE1 was zero. And you want, what do you want? Out. We want the high kinetic energy out. What about the velocity at B and the velocity at 4? Much, much greater, right. So the purpose of the jet engine is to develop thrust. How does it do it? Increasing the velocity. So if I said the forward thrust was the difference between the exit velocity and the inlet velocity, that's true. But that's something else multiplies that term. What do you think it is? Let's take a look at the units. This was Newton, wasn't it? Kilonewton. What is this? Meters per second. What do I need to multiply just to get the units to work? What do I need to multiply? Kilograms per second. Kilograms per second. Units kind of lead you sometimes to the correct answer. So what do I need to multiply this by? M dot. M dot. Now we know that a little bit of fuel is added, but the mass flow rate of the air coming in and the mass flow rate of the air going out is essentially the same, so we just left it as 1 m dot. So it's just m dot times the change in the speed. Okay? I was going to solve a problem, but I see I'm out of time.